In this video, we're going to have a look at the differences between batch processes and continuous processes. So first of all, let's give ourselves a couple of definitions to help understand what these words mean. So a batch process is a process that's completed in a series of steps rather than continually running. A good example of this is fermentation. And the other example that you've been learning about is the laboratory preparation of ammonium sulfate. That would also be a batch process. A continuous process is one that is going to run quickly all the time, as long as it is supplied with the raw materials needed for that reaction to happen. The example that we've covered previously is the Haber process, and we're going to have a look in this video at the industrial process used to produce ammonium sulfate. In terms of batch and continuous processes, we need to understand some key features of them. So what I've done here is I've actually changed this table. So you want to change the table in your books. So it says on this side batch, and this side here, get rid of this and just put continuous as the heading here. So I'm gonna add some bits of information to these. Batch processes, they tend to be quite slow processes, and associated with that, we tend to get higher energy costs. You have something running, you stop the process once it's done, then you restart it again, and therefore there's going to be higher energy costs linked to those stop and start processes. That can make it more expensive in order to run a system where you stop and start and stop and start, which we can put a reminder in there that this is a stop and start process. Okay, so you do your reaction, you get your product, and then that batch is done, you then start again, and that adds to energy costs and financial costs. Tends to be done on quite a small scale, so you don't make huge amounts of product in one go, and because of this stop-start nature, the process is labor intensive. So you have to have people there to stop and start the machinery, set it all up, put the raw materials in, and go again. The example that we've talked about is fermentation in the production of alcohol. That would be a batch process. Compare this to continuous. Continuous processes are fast, so they are much quicker than the batch processes. They tend to be cheaper because you just leave it running. There's not a stop-start process, and often this means that they can be automated, so they will just keep going, therefore less labor intensive, less cost linked to that. So it can be slightly cheaper, as we've said. The reaction, for the reaction to work, has to be supplied constantly with the raw materials. So supplied constantly with raw materials. So you have to be given the reactants required to the system in order to keep it working. And this process tends to happen on a large scale. So the production is on a large scale production. So therefore it's linked to industry, would be using these types of processes to make them cheaper, faster, and make larger amounts of products. The example that we mentioned earlier is the Haber process. That would fit these criteria as a continuous process. I'm just going to add one more bit to the video for you. Here's a little flowchart showing you the stages that have to take place in order to produce ammonium sulfate, and this would be as in a continuous process. This is an industrial process in order to produce this ammonium sulfate. Okay, so you can see if you work your way backwards, we know from earlier on that we need ammonia and sulfuric acid as the raw materials. Ammonia, we have been learning, comes from the Haber process, and the Haber process has raw materials of hydrogen and nitrogen. If you remember, the nitrogen, 8% of the air is nitrogen, so that's going to be collected via fractional distillation from the air to go in to make the ammonia. And hydrogen we can obtain from natural gas, or we can get from water in order to get the supply of hydrogen that's needed to react to make the ammonia. On this side, we have to make our sulfur sulfuric acid, sorry. In order to do this, remember sulfuric acid, I'm just going to put the formula here to remind you, is H2SO4. So we need supplies of hydrogen in order to make this. So this is going to come from our water. Our sulfur trioxide is taking sulfur, reacting with oxygen from the air, and then these two will come together in order to make the sulfuric acid, which then goes with ammonia to make the ammonium sulfate. So you can see it's lots of different steps in order to get to the ammonium sulfate, and this then would be done on an industrial scale to make large amounts of this as a continuous process.